Hey everybody, I am going to show you how to work out all of the test questions from our Unit 1B Assessment A. So follow along with me. If you need to fast forward to look at certain problems, go right ahead. Number one, and you got the multiple choice on the front page. Number one just says solve the equation. So first you'd want to distribute, and that would give you 10x minus 4 equals 8x. Now you got to solve for x. I'm not going to move the 8x over. I don't want to deal with 0 on the right side, so I'm going to start by subtracting 10x. And that would give me negative 4 equals negative 2x. Watch your signs. And then divide by negative 2. And x would equal negative divided by a negative right there is positive 2. So your answer for number one would be A. Number two, which of the following has no solution? Now, the x's need to be the same on either side to be a special case. So I don't know, you could just start by working these out. So A, choice A, I would distribute. And then I'm going to step back and look at it. I don't want to waste my time solving every single one of these. So if you guys notice, there's 4 x's and 5 x's. The x's have to be the same for it to be one of the special cases. So it's not A. I'm going to do process of elimination. If I look at B, I see that I could combine like terms over here. 5 plus 3 is 8 x's. This one is also not a special case because there's a different amount of x's on either side, so it's not B. For C, okay, when I put the numbers together on the right, I get 6x, 10 minus 5 is plus 5. Of course, the answer is D, the very last one. This one is infinite solutions. You do have the same number of x's, but the number's the same as well. So everything's going to cancel. And you'd have like 5 equals 5. That's infinite solutions when it's the exact same thing on either side. So let's hope it's this guy here. 3x minus 15. 7 minus 4 is 3x, and then there's that minus 5. So now when I go to get the x's together and subtract them from both sides, the equation looks like negative 15 equals negative 5, which is not true. So D has no solution. Number 3, which of the following is a solution to the inequality? You could do a couple things. For me, I'm going to do the quickest way. You could like plug these numbers in one at a time and just see if like they make it a true statement. I want to go a little bit quicker than that though. So what I'm going to do is solve this inequality. And then I can kind of pick out quicker which one is a solution. So 12 plus 11 is 23 divided by 6. It is going to work out to be a fraction. 23 over 6. If you like that better, you can plug that into your calculator and divide it, which it's just, it's a decimal, like 3.83 repeating. So think about that maybe. I need numbers that are bigger than 3.83. X has to be greater than that. So let's think about this here. It's got to be bigger than 3.83. So it can't be C. 3 is not bigger than. Negative 3 is not either. Over here, 7 is good to go. This is the exact fraction I got. So that is 3.83 repeating. But that's not bigger than itself. If the or equal to line was there, that one would work, but it's not. So 7's the only number that's bigger than 3.83 repeating. So D. All right, number 4. Write an inequality to match the situation. So Paul's goal is to eat at the most 450 calories. So calories is your x, that's your variable, and the number I'm obviously looking at is 450. So here's my thought process, guys. This is the calories that Paul wants to eat. Paul wants to eat at the most 450. Otherwise, he's going to go over his goal and he's going to gain a bunch of weight, I guess, or I don't know. So I think about that and I say, all right, at the most, the calories at the most. So that means he needs to eat less than 450 calories. And it sounds like he can eat exactly 450 and be okay. 450 is the most. So there's my inequality, which would be C. All right, on to the second page here, number 5. Solving each equation on this whole page, or at least up until number 10, for x. Probably not number 12, number 10. Solve all of these for x, show your work. So I'm going to draw my line and just start moving things over to the other side. Do not multiply by 3 first. You have to take care of this 8. Whatever's connected to or touching x, the 2 and the 3 here, save those for the end. That's a common mistake. People will multiply by 3 first, so be really careful there. Now you're going to multiply by the 3. So it'd be 2x equals negative 30. Last step is to divide by 2. Watch your signs. Negative divided by a positive is negative 15. For number 6, solving for x again, I'm going to move the smaller x, and I'm going to subtract 6. So that gives me 3x minus 5 equals 11. And then I'm going to add 5. 3x equals 16. Do not let this one scare you. Yes, it is a fraction, but that's okay. So x is just going to equal 16 over 3. You can leave it like that. If you'd rather divide it, you can, or like turn it into a mixed number. 5 1/3 is okay, or that's just 5.3 repeating. All mean the same thing. Number 7, so here's one, it's a literal equation. Number 8 is a literal equation as well, where you have other variables involved, but try not to let them scare you. You're still solving for x. For number 7, you're going to start by undoing that fraction, that divide by 5. So multiply both sides by 5, and it's mx equals, you guys can actually multiply those numbers there, 2 and 5, so call that 10y. Again, don't let it scare you. You're multiplying by m, so just do the opposite and divide by m. So it looks bad, but x is just 10y divided by m. Number 8, so again, solve for x. You want to move this whole 6y term first. So you're going to start by adding it over. 5x is left on the left side. When you're multiplying, like we saw on this one, you can multiply anything. But guys, you can only add if they're like terms. 13 does not have a y on it, so you cannot combine that with 6y. You just have to leave them separate and write it 13 plus 6y. Then come over here and divide everything by 5. So x would equal 13 plus 6y divided by 5. Again, those literal equations look really bad, but kind of once you can get past that, hopefully it's not that bad. Number 9, your first step is to always distribute when you're solving a multi-step equation. So that would be 3x plus 6 equals 5x plus 6 minus 2x. Then I'm going to combine like terms. Those x's, 5x and negative 2x, are on the same side. So I'm just going to do that like it looks. 5 minus 2 is 3x plus 6. All right, we kind of saw these on the front page. I'm going to stop right here. I noticed that it's the exact same thing on either side. When that happens, this is infinite solutions. Both sides say 3x plus 6 and 3x plus 6. There are unlimited answers to that thing. Number 10, start by distributing here as well, except be careful. You got to take the negative 2 or the negative with it when you distribute the 2. So negative 2 times x is negative 2x. Negative 2 times positive 5, watch your signs, is negative 10. Okay, distribute first. Then I'm going to combine like terms. those x's are on the same side. Just do it like it looks. 8 minus 2 is 6x minus 10 equals 3x plus 17. And then I'm going to subtract 3x from both sides. So 3x minus 10 equals 17. Oops, running into the other problem here. Oh well. Add your 10 over. 3x equals 27. And then last step is divide by 3, which comes out nicely. X is 9. All right, moving down to some word problems here. So write and solve an equation for the following situation and label your answer. At the baseball game, Sam bought a soda. So the soda was $3.75. 3 hamburgers is what he also bought. Don't know the cost on all of that there. I do know, though, that he spent $16.50 on the food. So I want to figure out how much did one hamburger cost. That last sentence, that question, shows you your variable. H is the cost of a hamburger. So we want to figure that out. We're going to use H when we write our equation. So on one side, I put the total, which I know he spent $16.50. Exactly. This is not an inequality, and it tells you it's an equation. On the other side, I want to represent how much he spent. Well, he spent $3.75 for a soda and then 3 hamburgers. So that's where your H comes in. Add on to that 3H. And then we're just going to solve that. So first step is to subtract 375. So 3H equals 1275 when you subtract those two numbers. And then divide it by 3. And the cost of a hamburger, so label it with your dollar sign, is $4.25 when you put that in your calculator. Not too bad of a price. Next page, number 12. Circle all of the following in which 2 is a solution. All right, so we got to look at these graphs here. And remember, if you forget, open circles mean you didn't shade over 2. 2 does not work if it's an open circle. So number 1, 2 is not shaded in. Okay, that's the only one where 2 is has a circle above it. If you look at number 3, and I'll just do kind of like process of elimination, look at number 3. Here's 2. We shade on the number line where the solutions are. So this one's not a solution because the shading's over here. Numbers less than or equal to -2. So that one doesn't work. On the other 2, and it looks like, read the directions, you can circle all of them that work. Both of these work. Look why. On number 2, we did a closed circle over 2. When you shade over it, that means it works. So that one's good. And then here's 2 right here, which the shading covers it. So that one's good. 2 answers. All right, let's clear that out. Number 13, write and solve each inequality. Sorry, we're not writing it. Solve the inequality and then graph it. So get your line going. If you guys see this where there's a fraction, I don't like that. And what I do is I put the x on top with the 3. So that'd be the first thing I would do. I feel like it's easier that way. Then maybe you can see, oh, I just moved the 4 first. I'm going to multiply by 4 on both sides. So it's 3x. Bring your sign down. Remember, guys, when it's inequalities, you have to think about when you flip the sign. So just a reminder, when you multiply or divide both sides by a negative, you're going to flip it. That's not going to happen here because I'm dividing by +3. So keep my sign as a greater than or equal to there, and that's going to be 16. So that's my solution. Here, let's do this. I do have to graph it. So answer was this, maybe. There we go. And you're going to put, 16 in the middle there. 17, 15. It is a closed circle because you have the or equal to. and X is sitting on the right. When it's on the left, you can follow the sign the way it points, but this is the other way, so it's pointing right, so I'm going to shade left. I want numbers that are smaller than